Hi, a line from the origin meets these two lines at P and Q. Now this line is represented by the pink and this is represented by the blue line, and this is the origin. You are supposed to find vector PQ. Now what we can do is we can change this to a vector equation form. So let's call this L1 and this L2. Alright, so this is L1. L1 is here, L2 is here. Now let's change L1 to a Cartesian equation form. So you have L1 passes through this point 2, 1 and minus 1, and the direction vector is given by mu 1 minus 2, 1. Now, so what is this point here? This point is then represented by xyz, which is, what is the coordinate? Now, since P is on the line L1, so this will be equals to 2 plus mu 1 minus 2 mu minus 1 plus mu. Likewise, Q, what is the coordinates of Q? And since Q is on L2, so this can be written as 8 over 3 plus 2 lambda minus 3 minus lambda 1 plus lambda. Okay? Now what's next? Now, since they are parallel, so you find that the I component of this over the I component of this will be equal to the scalar quantity. That means the I component of this divided by the I component of this will be equal to the J component of this divided by the J component of this, and the K component of this divided by the K component of this. They will be equal because they are parallel. So let me write down the equation. So 2 plus mu over 8 over 3 plus 2 lambda will be equals to 1 minus 2 mu over minus 3 minus lambda minus 1 plus mu 1 plus lambda. Now, what we can do is we can try to solve for mu and lambda. Once we get mu and lambda, we substitute back into these two expressions. We can get the vectors PQ easily. Now, how to solve this? Now, let me tell you something that some of you may not know, right? That A over B, let's say A over B equals to C over D. Now, this will also be equals to A plus C over B plus D, and which is also equals to A minus C over B minus D. Okay, you can try that out on your own, okay? But it can be easily be proven, but I will not go ahead to prove it. Let's concentrate just on this sum for the time being. Now, let's combine these two. Alright, then we can easily get rid of lambda. So I use this plus this, alright? So the numerator plus each other. So it will be minus mu over minus 2. So this is mu over 2 actually. Now let's get rid of lambda also. Now how to get rid of lambda? This one I multiply by 2. So I have minus 2 plus 2 mu over 2 plus 2 lambda. Then I use this minus this minus this. So the numerator minus the numerator, denominator minus the denominator. Alright. So this minus this, I get 4 minus mu. Okay. Now I use this minus this. So I get 2/3 here. Now this and this can cancel. Alright, and this will be equals to mu will be 12 minus 3 mu. Okay. Now I work out mu is equals to 3. Okay. Now so what is this point? This point is actually 2 plus 3 is 5 minus 5, then this is 2. Okay. Now, once we have gotten mu, we substitute mu into this and this, or any of this pair of expression, you will be able to get lambda. Let's use these two. So we substitute mu is 3 into this, so you get 1 minus 6 as a numerator, so you got minus 5. Denominator is minus 3 minus lambda. Over here, minus 1 plus 3, you got 2. Denominator is 1 plus lambda. Let's do a cross multiplication. So before that, this then becomes all plus, alright, because you can cancel the negative. So let's work with positive. So I have 5 plus 5 lambda equals to 6 plus 2 lambda. Okay, so I have 3 lambda here and I have 1. So lambda equals to 1 over 3. Now I got lambda is equals to 1 over 3. Let's put inside here to find q. So q will be, so this is the numerator, here will be 10 over 3. Then here will be minus 10 over 3. Here will be 1/3, so 4 over 3. Alright, so this is q. So how to find PQ? We are running a bit out of space, never mind, coming to an end. So vector PQ will be OQ minus OP. So what is OQ? 10 over 3 minus 10 over 3, 4 over 3 minus P is 5 minus 5 and 2. So what will you get? Minus 15, so minus 5 over 3, 40 over 3 minus 2 over 3. Okay? The next lesson we will be working out this particular question. Find the distance of this particular point from this given plane measured parallel to this line. Now, this is the plane and this is the line. we are not looking for the perpendicular distance, but we are looking for the distance that is parallel to this line. Perhaps you can try to attempt this question on your own. In any case, I will work out the full solution and I'll be putting the URL link in the description below. For those who are interested, please click on it and we hope to see you again. Have a nice day.